I'm going to share with you today something
Not doing vectors.
that will, it will annoy you. You will say, Mr. Bennett, why didn't you show it that way last year?
Oh, so it's gonna be like easier. So now we're gonna be mad that you didn't show it from
Yes, you are.
Why wouldn't you show this last year?
Well,
You have to learn.
Just so we ask that question this year.
yeah, sort of, yeah. When we did vectors last year, we do it in a sort of a visual fashion, you know, where you put them tip to tail and you draw the scale diagrams and all that stuff, right? And we know that that is mathematically not as accurate as it should be, right? So what if I were to show you a way that were much simpler and much more accurate? That'd be good. So let me just show you sort of, because you have to understand the whole tip to tail thing before you do this. This is really just an algorithm, a series of steps, whereas actually putting the tip to tail sort of gets you understanding of the idea of vectors. So what if I were to do this? Here's vector A right here, right?
Yeah.
And if I click on components, have we talked about components at all? We did talk about components briefly in the one unit where we found the horizontal component. Do you remember doing ones like this? Do you remember doing questions like this, right? Where you had the applied force here and you had the FH, the horizontal component, and there was a vertical component? Well, same idea, right? Okay, so I have AX and AY, okay? So let's just say that I wanted to, if I were to add vector A, B, and C, how do I do that? Let me just clear this again. I'm going to restart. Get rid of my components. I'm going to take vectors A, B, and C, and how do we add them together? We place them tip to tail. Okay? So I'm going to take A, and I'll just go down here, and then I take B, and then I take C, right? And I place them tip to tail, right? And so would you agree that, which I'm going to draw in blue, would you agree that this vector here would be the result, right? And last year, Jory, you would have taken a ruler and a protractor and done all that and figured it all out, right? And it would have been, when you add three vectors together, no, just sit and watch. It would be relatively close. Okay, now Jordan's idea is to take the components. So I'm going to take the components. Now, what if I were to just take the x and add all the x's together? Okay, that's going to have to go like that, right? I'm going to add all the x's together. Okay, and I'm going to get this little guy right here. Right, and could I call that Rx, resultant x? Yeah. It's the x component of the result. It's the resultant of all the x's. And then I'm going to take all the y's. Thanks. I'm going to take all the y's and I'm going to add them together. And then this would be my...
Dude, that's it.
Ry. And now if I take Rx and add it to Ry,
What's that?
let me get that out of the way.
That.
Would you look at that?
And then
Would you look at that? Now, how easy is it to add all the x's together?
Very.
Easy, because they're all pointing either right or left, so they're either positive or negative. You don't have to use a ruler. You don't have to use a protractor.
I'm quite mad.
It's so much easier.
it's all A squared plus B squared.
Exactly.
This is
Okay. So, pardon me? When the final angle you just used, because is the x and the y always going to be 90 degrees?
Yeah.
Absolutely. So it's just going to be opposite over Jason. It's always going to be a second function tan at the end.
Well, can you do like A squared plus B squared is C squared?
You could do that. Well, that's what you're going to do to get the R. Zach was asking about the angle. Right?
This is so much easier.
Yes, it is. But you only get it because you understand about tip to tail.
But where's?
You wouldn't get it so well if you didn't know what tip to tail meant. Jordan.
You could easily do the A squared plus B squared equals C squared, and then do like sine and like how many it, right?
Sure.
How are you gonna find like AX and BX?
How do we do that? Good question. how do I find the x component here of A? Well, the x and the y are always going to be 90 degrees from each other, right? So in fact, let me just go to a new page here. We've already done that, right? When we did these questions, right? We already found if that was my applied force, that was my horizontal, and that was my vertical. You know that angle, so it's just basic grade 9 math, right? That's all it really is. SOHCAHTOA, exactly. Okay, so you've got one handout.
We have these every time. What are we doing with this one? You're giving us more?
Well, I should have given this one first. This little lesson I need to package up a little bit. I haven't packaged this lesson up very well.
We're recording this still.
Okay, so you've got the second handout here. The second handout, which says vector components. Draw each of the following vectors on a Cartesian coordinate system and break them down into vertical and horizontal components. Let's do the first one with you. Okay, let's just do it here. We've got D equals 30 meters at east 30 north, right? So, Jory, let's draw that vector first. East 30 north is east 30 degrees to the north, right? Right? This is east. And then you go 30 degrees to the north. Okay, so this is, oh, they're both 30. I hate it when textbooks do that. They always do that. They put the angle and the length the same. Now, do you need a protractor to draw that? No, it's just a sketch. Make it into a triangle. Let's call, because the whole thing is called D, we're going to call this one dx, and we're going to call that one dy. I know it's a right triangle, so therefore it's basic grade 9 math, right? Basic trig. The dx is the adjacent. The dy is the opposite, right? So in other words, cosine 30 is equal to adjacent dx over the hypotenuse, which is 30. So in other words, dx is equal to 30 cos 30. 30 cos 30. No, because you're taking the cos of the angle. You should have got 26.0 actually. 25.98. So that's the x component. Is it always going to be cosine, the x?
No.
Not always. More times than not, it is just the way we sort of do things, but not always. It sort of depends on how your triangle is drawn. So of course that means then that dy is simply going to be 30 sine 30. If one is the cos, the other one's the sine. Now shouldn't it just be like 4? Like 26 and 4 should be 30, shouldn't it? No? Like, no? 26 and 4? No, that doesn't work that way, does it? No, it doesn't. Some people still believe that, though.
Seriously?
Yeah. 30 sine 30. 15. Now, do you remember the whole positive and negative thing?
No.
To the right is, of course, positive. To the left is, of course, negative. Does that matter? Absolutely does. When we did this adding on the previous page here, when we did it like this, absolutely, right? The CX is to the left. It's negative. It's green in this case. So, yeah. So these would both be positive. That's right. That's it. That's all there is to it.
Can you count it?
Should I give you a little bit of time to do those?
You should just do it all of us.
I'm not doing it. I'll do them all.
Yeah, you are.
Just all of us.
Do one more, this one goes the other direction.
Okay. We'll do B. B is V bar equals 100 meters per second at west 40 north. V bar just means average velocity, right?
So the acceleration of V bar don't matter.
Not in terms of components. West 40 north is going to be
49.
west 40 north it's 100. So we would call this Vx, we would call that Vy. Ask yourself, is the x adjacent to the 40? Is the x adjacent to the 40? Yes, it is. So therefore, it's going to be the cosine or sine? Cosine. So Vx is going to be 100 cos 40. $76.6, but because it's to the left, right? Because this is actually that direction, so that is that way. So this is going to be minus 76.6. Vy is going to be 100 sine 40. 64.3, but up, right? So it's going to be positive 64.3. That's really all there is to it. I'll give you guys one to try. I did put a QR code on the back.
You have to just scan it with iPhone.
You can scan it with your iPhone. I can get. I think I put the QR reader on that iPad. I'll put it on a few others. Okay. The solutions are there. They're also in the green binder. How about you do just like, really, just pick one because they're really not.
Which one, D, E, or
C, D, or E?
what's F and D?
F would be force. T would probably be torque. Stefan is asking, and this is a common question they get all the time, is the x always going to be the cos? The answer to that is no. How would I draw the angle so that the x was the sine? How would I have to draw the triangle, Mary, so that the x was the sine?
So,
Would that be opposite?
You want to come draw it?
just read on those.
Was it like C?
I never see.
Like C?
It's gotta be southwest.
South
Southwest.
16 west?
Yeah.
Okay, so that would be like this, right? South 16 west, right? Is that all right? South 16 west? 23. They're calling this acceleration.
I have a question.
So that would be AX and that would be AY. So in this case here,
You got a gap, what?
Wait.
Why is it drawn?
Yeah, why is it
South?
going that way?
16 west. So you look south, right? And then you have to go turn west, right? So to the west, right?
Oh, Jesus. I drew that so hard, it hurts.
No. From here, that's south. From the, well, I can draw it like this if you want. Right? North, south, look south, and then go towards west.
Oh, that's pretty loud. I'm gonna do that. Is that all right?
Right? So in this case here, I think it's always right. In this case here, the x, is it adjacent or is it opposite? It's opposite, right? That's the opposite one. So in this case here, AX is going to be 23 sine 16.
Oh my goodness.
And AY is going to be 23 cos 16. So really, it depends on whether or not the angle is measured from east and west, or if it's measured from north and south. That's what matters.
I think I still got the answer though.
Oh.
But you might have got them backwards.
Does AX have to be that bottom one?
AX has to be the bottom one because it's the horizontal component. It's the sideways one. This can't be AX.
AY can go horizontal?
No. X means horizontal. Okay, so, yeah, but did you get them in the right spot?
No.
Well, then you didn't get the right answer. 23 sine 16 is 6.34,
One month only.
and 23 cos 16 is 22.1, which the x is actually negative, right, because it's to the left. The y is also negative to the left, right? If you got those numbers but reversed, Kyler. If you got those numbers but reversed, that's like saying you won the game because the score was 5-1, even though the other team got 5 goals.
No, it's not like that.
Not quite, but very similar. Okay? Yeah, so don't make that mistake. Okay.
Like, get all the answers right, but not the odds right.
Yeah,
Apple.
possible. To get the numbers right, but not labeled correctly, right?
I don't remember that.
All right.
Yeah,
So-
I do remember you screwed up.
Let's go now to the adding part. So go to the other page, Quinn. Go to the other page here. The other page completely.
Yeah, we made a mistake.
Salt intended. Quinn,
What?
stop talking so I can finish. Add the following vectors. Now, the nice thing about doing these things by components is that when we did this graphically, the more vectors you add, the more error you introduce, right? The more it can be off. Whereas when you do it by components, no problem. And in fact, if you can program a computer, you can do it by components relatively easy. You can come up with a program that actually works for that. Okay. In fact, I did have a student actually do that. She wrote a program that actually had vector sums. I can show you that later. So add the following vectors: 0.5 kilometers north, 20 east. Okay. So looking at that picture there, we're talking about D1 is like this, right? North, 20 east, right? North, and then 20 to the east. And then from there, 0.3 kilometers west. And then from there, 0.8 kilometers west, 50 south. So west, and then 50 south. Takes me to down, well, not quite. Something like that. I sort of ran out of room there a little bit, right? Okay, now obviously, again, if you do it by a protractor, you're going to introduce some error. Let's do it by components. Okay, so you guys just follow along. Really, the component method is very simple. Okay, so the component method, the first step is to find the x and y components of each vector. So the first thing, 0.5 kilometers at north 20 east, 0.5 at north 20 east. So north 20 east looks like this. There's north, 20 east, 20 in there, 0.5 there. I'm going to call these, they're all displacement vectors, so we're going to call them D1. So this is going to be D1x, and this is going to be D1y. In this case here, the x is actually opposite, right? So D1x is going to be 0.5 sine 20. .5 times sine of 20. 0.17. Now, positive or negative? The x is to the right, so it's positive. Now, I would suggest what you do is do the x in one column and the y in the next column, and then when you add them, they're all nicely lined up, right? D1y is going to be 0.5 cos 20, 0.47, also positive because it's up. What do I do with the next one? It's 0.3 kilometers west. 0.3 west. So D2x, do I have to draw a triangle? There is no triangle. D2x is simply minus 0.3, isn't it? It's minus 0.3. And D2y is 0. There's no y component. It's 0. Last one. 0.8 at west 50 south. .8 D3y D3x. D3x, this time the x is adjacent, so it's going to be 0.8 cos 50, 0.8 times cos 50, or 0.51. But to the left, so it's negative. D3y is going to be 0.8 sine 50, 0.62, down, so also negative. Now, Kyla, do you see if you get the x and the y backwards, what happens? Like if I got the x and the y backwards, even though I got the right numbers, I'm not going to be adding the proper x's and the proper y's, right? Yes. Yeah, so you got to make sure, right? Now, do you see how if I've got my x's in a column, it's nice and easy to add them? Or you've at least got them separated, right? You can sort of see the two. Okay, so we've done all that. If you flip the page, it says, next step, add all the east, west, or x components. Right? So I like to write Rx equals the x component of the resultant. Rx is going to equal these x numbers here, 0.17 plus minus 0.3 plus a, do I really need the plus? Minus 0.51. So that's my overall x component. 0.17 minus 0.3 minus 0.51 giving me an overall x component of minus 0.64, so it's going to the left. My ry is going to be 0.47 plus 0 minus 0.62. Negative 0.15. Both negative, so it's down to the left, which is what our picture originally showed. I guess this is, you should have written that down under add all north, south, y components. How do you find the overall resultant? You've got the x component, you got the y component. Are they always going to be 90 degrees to each other? Yeah, that's what x and y means, right? It's probably a good idea to redraw the x and the y. So there we've got minus 0.64. There we've got minus 0.15. There's my overall result. R squared is, do I need the negative sign in there? I'm just going to square it. Right? So I get 0.64 squared plus 0.15 squared, square root, 0.66. Does that seem about right? 0.66? Done? All right? Okay. This seems a little on the low side to me. Okay. You also have to, of course, do the angle. Okay. Is the angle always going to be inverse tan? Is that always going to be a tan one? Yeah, because you always have the opposite and the adjacent. The opposite and the adjacent are the x and the y, right? So you just got to pick which one is which. Opposite to the theta is the 0.15. So 0.15 over 0.64. Yeah, you do. It's part of the resultant. I get 13.2 degrees. So that's going to be west 13, so. And this is 0.66, is it meters? I don't know what the deal is there. Kilometers. West 13 south. So easier than ruler and a protractor?
It's like a lot of creating that stuff that I'm.
No, it'll come back to you. Okay? It looks like on the bottom of page, page there it says assignment page 84, numbers 1 and 2 in the book if you like. Or if you prefer, the other sheet has vector addition by components. I don't know if there's enough room here for some of you, the big writers. You know who you are. Okay? These ones are all 2 vectors. Well, I guess the last one's 3. And the next one here, vectors in 2 dimensions, exactly the same thing. So there's 6 questions, 7 questions for you to try. The solutions are on the back there. The
Except for like
code.
those who own this phone.
It's fine, Mary. I have a phone like that.
Good. That's the job.
Yeah, it does. It works fine. The solutions are in the green binder. I can get out a couple iPads if you want to try the scanning.
10% battery.
Better safe. Actually, 10%